Okay, morning guys. So the topic is DeepSeek, the open source AI challenger. So in 2023, a new AI company entered the scene, DeepSeek. At this time, the AI field was dominated by big players like OpenAI, Google, and Meta. Most of these companies kept their models locked behind APIs and subscriptions. But DeepSeek took a different approach. They went open source, making their AI models freely available for anyone to use and modified. This turned out to be a very smart move. In 2024, they released DeepSeek Coder, an AI specialized for programming. It wasn't just good. It outperformed GitHub Copilot by 12% on human eval, a key benchmark where AI models generate code from scratch to solve problems like sorting algorithms and file parsing. On real-world coding tasks, like debugging Python errors or writing database queries, it achieved 15% faster completion times than Copilot in user studies. But the real shocker came with project-level coding. When they were asked to build a basic web app with user authentication and payment processing, DeepSeek Coder generated 94% of boilerplate code autonomously, flagged 3 security vulnerabilities Copilot missed, and cut development time from 40 hours to 9 hours for junior engineers. Our level ups would be so much better. Then came DeepSeek version 2, a massive 70 billion parameter model. But here's the twist. Training a model like GPT or Llama typically costs hundreds of millions, a budget that would resemble a phone number. DeepSeek did this for just $6 million. How did they do this? They didn't just brute force it with endless hardware. Instead, they reimagined the architecture. While using clusters of NVIDIA H100 and H800 chips, their secret was mixture of experts. Mixture of experts is a clever architectural design for AI models that mimics how humans delegate tasks to specialists. So say you have a team of specialists that has a math expert, coding expert, and a language expert. When you ask a certain question, the router will decide which specialist or specialists to consult. Need to debug code? I guess we'll activate the coding expert. Need to solve a calculus problem? The math expert will take lead. This way, the model doesn't need to waste energy firing up all its neurons for every single task. Okay, sorry. So, chain of thought, but it doesn't just stop there. DeepSeek version 2 also employs the chain of thought. Here's what this means. Humans don't just blurt out the answers. We think through our problems. Well, most of the time. If I ask you this math problem, what is 22 plus 88 plus 23 plus 2? You'd have logical steps to solve it. So you'd say what 22 plus 88 is, which is 110. 110 plus 23 is 133, plus 2 is 135. So the chain of thought forces the AI to show the same step-by-step logic, mirroring how humans logically work through challenges, like how we did this math problem. The results spoke for themselves. DeepSeek quickly climbed the ranks, landing in the top 10 AI models in benchmarks. More importantly, it proved that open models could compare with the biggest names in AI, changing how we think about future AI development. Some positive impacts is democratizing advanced AI capabilities. DeepSeek's ability to train high-level performance models at a fraction of traditional costs fundamentally changes who can participate in AI development. By reducing the financial barrier from hundreds of millions to just millions, they from only well-funded corporations. This cost revolution enables smaller organizations and individual researchers to access capabilities that were previously exclusive to tech giants. The technical foundation for this achievement lies in 2 key innovations: mixture of experts, which I explained before, and hardware optimization. Through custom software improvements like highly efficient CUDA kernels, DeepSeek maximizes consumption of available processing power, getting more performance from each compute unit. Second, the environmental impacts. DeepSeek addresses one of AI's most pressing challenges, its massive energy consumption. The approach demonstrates that performance doesn't have to come at an environmental cost through several innovations. energy-efficient training. The mixture of experts architecture inherently requires less computation, directly translating to lower power consumption. Model maintenance. Their architecture allows for targeted updates rather than a complete retraining, conserving resources over the model's lifecycle. Then thirdly, it's open source. Making models openly available creates systematic benefits that extend far beyond simple cost savings. Some of these benefits is security. Community scrutiny of open code leads to more robust systems as vulnerabilities are identified and patched collectively. Education. Open models serve as valuable learning tools, allowing students to study and work with production-level AI systems. Economic impact. The accessibility lowers barriers to creating AI-powered businesses and services. Fourthly, changing industry dynamics. DeepSeek's success has created a ripple effect across tech industries, compelling major players to reconsider approaches. The visibility of their open, efficient model challenges the assumption that advancements require massive resources and closed systems. This is driving a measurable change in how other organizations develop and release AI technologies. Some negative impacts is hardware dependence. DeepSeek's entire operation hinges on NVIDIA's chips. This is a huge gold standard for AI training. But here's the problem. Geopolitical vulnerabilities. US exports control could abruptly cut off China's access to these chips. While domestic alternatives do exist, they lag behind the performance of NVIDIA's chips. Scalability risks. Even if DeepSeek hoards these chips today, future model scaling will demand next-generation hardware that may be off-limits. Then there's also a question of job disruption. AI-generated code is getting better every single day. It's able to automate 40% of boilerplate code, which could reduce demand for developers. And beyond coding, AI automation might impact content creators, designers, and other tech-adjacent roles. Thirdly, open source is a double-edged sword. DeepSeek's open source allows anyone to access, modify, and improve these models for beneficial purposes like education and research. But the same openness also enables bad actors to strip away safety controls and repurpose technology for harmful uses like phishing and disinformation. What's next for DeepSeek? First, they're moving beyond just text. Like GPT 4.0 and Gemini, DeepSeek is developing multimodal capabilities, meaning it will soon understand and generate images, audio, and video with increasing sophistication. This is not just a flashy demo. It's about creating AI assistants that can truly understand our multimedia world. Perhaps more importantly, they're working to shrink these powerful models down to run locally on your devices. Imagine having an AI assistant that works seamlessly on your phone or smart devices without needing constant cloud access. This could mean faster responses, better privacy, and reduced costs compared to today's cloud-dependent AI services. But the biggest battle may be over openness itself. As DeepSeek open models continue to improve, they're putting pressure on companies like OpenAI and Meta to justify keeping their best models locked away. Will this lead to more open AI across the industry, or will administrative concerns push us towards more closed systems? The answer could determine whether AI remains democratized or becomes controlled by a few powerful gatekeepers. Of course, none of this can happen without solving the hardware challenge. Today, DeepSeek, like nearly every other AI leader, depends completely on NVIDIA chips. With growing tech tensions, China faces the critical question: can they develop competitive AI chips independently? This answer may determine whether companies like DeepSeek can continue competing at a global stage. What makes DeepSeek's journey so fascinating is not just about a company's success. It's about the fundamental questions that will shape our technological future. How will AI remain? How will OpenAI remain? How will we power these systems? And who will control this transformative technology? The answers will affect us from years to come. Thank you.